Hey, what's going on, guys? We're going to go over LeetCode question 572, subtree of another tree. So you're given the roots of two binary trees, root and subroot, and you have to return true if there is a subtree of root with the same structure and node values of subroot and false otherwise. So in this example, if you look at the subtree circled here, it has the same structure and values as subroot, so we return true. In this case, it might look like we have an identical subtree with subroot, but there's an additional left node here, making this false. So the first thing we should consider is how can we make a function that checks if two trees are similar? The reason why is because once we figure that out, we can look at every node using DFS and looking if the trees are similar at every node. So we have to get the hard part out of the way first. So how do we know if two trees are similar or not similar? In this case, if we have an additional node here coming out of 2, and in this case, there's no additional node, so this just returns none, then we know that the trees are not similar. One has an additional node, and the other is just none. And it doesn't matter which way you look at it. If there's an additional node coming here, and this is none, so that stays the same, they're not equal, so we just return false for this node in particular. And we're going to do that for each node in the subtree, or for every subtree and root. And then whenever we do find that it's true for some node, we return true and just get the recursive out of the way. So let's just define a function called, let's just call it SameTree. And we're going to pass in the root and subroot. So for every recursive function, we need to have a few base cases, or just one base case that terminates the function entirely. So one thing we can check is if both root and subroot are none, then we know that they're similar, so we can just return true. So if not root and not subroot, by definition they're similar, so we return true. And we also know that they're not similar if, like I said, one node is none and the other actually has a value. So we can say if root and not subroot, or subroot and not root, then we want to return false. So we can say structures are not similar, right? And also, because we need the values to be the same, we can check if, the val properties are different, then we return false there. So if root.val is not equal to subroot.val, then we return false, right? So this is pretty self-explanatory. And the recursive case, because we want to check this for pretty much every node we're looking at, we need to make sure that both the node's left subtree and right subtree are identical to the subroot's left subtree and right subtree. So we need to return SameTree root.left and subroot.right, and it has to be the same for the right side as well. So we can say root.right and subroot.right. Okay, so because at this point it only works for the very top, the very root, we need to have another function that looks at every level, right? We need to find one that can work for every node we're looking at, and we keep going down until we reach like a leaf node, which means there's nothing else to process. So let's just call this isSubtree, and all we're going to do is pass in the root. And we know we need to terminate if not root, because there's no structure with root, we just return false. Okay? And the other case is if at whatever node we're at or whatever subtree we're at, if same tree is true, then we return true at that point and just stop running the recursion. So if same tree root and subroot, then we return false. Or sorry, we return true. Okay. And we need to keep running until we find that or we reach the end. So all we can do is say return is subtree root.left or is subtree root.right. And this makes sure that we can check both sides of a subtree, right? Like if we clear this out and, for example, we have this issue here where the twos are not identical. But then, even though the left subtree is the problem, we can add a 4, a 1, and a 2. And then this would make it similar, right? 4, 1, and 2, these are similar structures. So we always want to check the left subtree and right subtree. And if either of those are true, then we have a subtree. And finally, we just want to return is subtree root. Okay? So let's see if that runs. Okay, that runs well. Okay, and that submission works. So if we're talking about time and complexity, the time is going to be O of m plus n, or actually O of m times n. The reason why is because for every node m in root, we also have to check every node n in subroot. And worst case is we have to get all the way down to some subtree, and that's going to take m times n time. And the space complexity is going to be O of n, because if we're making these recursive calls, it's going to add n nodes to the stack. So that's the solution to this problem. It uses a lot of concepts from another binary tree question called same tree, which is basically this function right here. The only difference is we need another function that checks every node in root. So hopefully this helped you out, and stay tuned for the next one.